Hi, my name is Jason Clark, and I am the Extension Soil Fertility Specialist here at South Dakota State University. And I'd like to welcome you to our Soil Health and Nutrient Management section of the Master Gardeners class. I will be your voice this year because we can't meet in person due to the current pandemic, but I hope that I can, through emails and other ways and Zoom, can interact with all of you and help you understand how important soils are in gardening and flowers, in life itself, and how we can improve our soils to better provide the food that we need each and every day for our families, as well as just having some fun. So here we go. Let's get started a little bit. And with gardens, as well as with lawns and everything else, they come in all shapes, all sizes. Some are more ornamental around our houses, different flowers, different colors. All of these things that we love to see kind of green up and give color to our homes and our surrounding areas. And of course, we have those vegetable gardens, fruits, things like that that we want each and every year from those garden areas. So lawns and gardens take various shapes and sizes. And the soil that's used to grow that food is a very important component. And so in this chapter and in this section of the Master Gardeners class, we're really going to hit on some really key components of soils. Some we're going to go more into depth on, some we're just kind of hit the surface of. If you ever have any questions, feel free to reach out to me at any time though. But here is a quick outline of what we'll be covering in this class. So first of all, we're going to look at the soil composition. What makes up a soil? What are the particle sizes? What are the different components called? What are their attributes? What is a good soil? How can I improve my soil? The next thing we're going to do is the properties of those soils. Based on the soils we have, they affect different things, such as how much water they can hold, how well they hold on to nutrients, how well water drains through them. Do I have ponding on my garden or does it go right through? And within those soil properties, there's three basic areas. The first one is soil physical properties. What is the texture of the soil? What does it feel like when I'm holding it? What is the structure? Does it look like a sand pile, just lots of little tiny grains? Is it bigger cloddy type of structures? What is it that makes it up? The next thing is soil biological properties. So this isn't necessarily the soil itself, but it's what's living inside of that soil. What are the microbes, the fungi, the bacteria, and how do they influence growing crops and flowers and fruits and vegetables? The next thing is soil chemical properties. This is referring to how many nutrients the soil can hold. What nutrients are they holding? How many are they holding? What is the pH of the soil? How acidic or basic is it? The next topic we'll be looking at essential plant nutrients. What nutrients are essential for plants and where do we get them from? And the last area, which will have several subsections in, is how do we improve our soil properties so we can grow the fruits and vegetables, flowers and trees better. So this is our outline for the class that we'll follow through with several different successive videos here in smaller parts. But first of all, we're going to talk about the soil composition, what it is that makes up a soil. So here we have our soil and we have our particles here. And these particles, some are big, some are small. They have different shapes, different sizes of them. And what's really important to note here is how much of this soil is solids and how much is pore space. So the solids are these particles here, and the pore space is those areas in between the solids. And in an ideal soil, what we're really looking for is we want about half of that space, half of that volume of soil to be solids. About 95 to 98% is typically a mineral, and the rest of it is organic matter, so living carbon-based plant tissues, roots, decaying organisms, things like that. Those are all organic matter. So things that are solid. The other half is going to be pore space. This pore space can be either water or various gases such as oxygen. And that can be anywhere from 0 to 50% water or gases. And based on how much that is, it helps the plant. So we need enough space in there for water, but we also need space left for gases such as oxygen. So these are basic parameters of what makes up a soil. So we want about 50% to be a solid portion and the other half to be pore space. Now these different physical properties we can measure how well they do based on how well the plants root. How deep can they go? Can they only go 6 inches and they hit something that's rock hard, or can they go down 2 or 3 feet? Drainage is another important aspect. Does the water stay on the soil surface, or does it drain through at a good rate so we can not have ponding on the surface? And also, we want good drainage, but we also want the soil to be able to hold water. So if we have a long time between precipitation, between irrigation events, that soil can hold enough water and provide what the plants need to be able to grow well. And these physical properties are strongly affected by two different things. The first one is soil texture class that we'll go into a little bit more depth on, and the second is soil organic matter. Is that carbon-based material? So that's a little bit about soil composition. The next part will be starting into soil properties, specifically physical properties, and we'll start out with soil texture and structure. We'll start out with soil texture. The definition of soil texture is the proportion of soil particles of various sizes in the soil mineral component. And what that is we have these different soil particles and we put them in class sizes, how small and how big they are. And based on the percentage of the soil particles of various sizes, we're saying that this is the texture of the soil. So for example, the components that we look at the most are the percent of sand, silt, and clay. And whether we classify it as a sand, silt, or clay is based on the diameter of the particle. So you can remember in our previous slide we had that the different sizes of the particles. You can see some were big, some were small, some were long and skinny. So based on the diameter of those particles, they fit into various size classes. So in this table here, we can see lots of different diameters ranging from less than 0.002 millimeters being a clay down here in this area, all the way up to boulder size, which are greater than 23.5 inches. But down here is where we're really going to focus on as far as a soil texture goes. So first of all, we're going to start out with the clays. This is anything that has a diameter less than 0.002 millimeters. And remember here that 1 inch is 25.4 millimeters. So if we're less than 0.002 millimeters, we are small. These particles are little. And then we go up just a little bit more to 0.002 to 0.05 millimeters. This is a silt. It's a little bit larger than a clay. And this next category are sands. And the sands have different ranges from very fine to very coarse. But most of the time, as far as soil texture goes, we just group all of these together as being greater than 0.05 millimeters and less than 2 millimeters. And then once we get above 2 millimeters, that 2/25 of an inch, all the way up to more than 23.5 inches, these are our gravels and our boulders. And for soil texture, we don't really pay attention to these with our gardens. We usually don't have too much into them. So this area right here, outlined in the green, this is what goes into determining our soil texture. So if we take the soil particles that we're concerned with, we want that sand, silt, and clay measurements. So we can kind of see here their different diameters. You can see as we go from clay to sand that they increase. But also we kind of want to bring this into real life. So we want to know relatively, what does this mean? What's the difference between these particle sizes? So if we say a clay particle is the size of a 1-inch postage stamp. So then what would be the size of a silt particle? That would be comparing it to a 12-inch basketball. So quite a bit larger. But then if we look at a sand particle and we compare it against those two, we're looking at a 100-foot grain elevator complex. So imagine a sand particle being that big and a clay particle is the size of a stamp. So you can see how large of a size difference we go from a clay-sized particle up to a sand and how small these are in the soil. But the shape is another characteristic that's really important to know, because these clays are actually a little different from our silt and sands. These are flat. So imagine a ream of papers just sitting on top of each other. They're stacks of papers and they're flat and they're very, very thin and very small. However, that also makes them very good for holding moisture and holding nutrients. Whereas if we look at our silt and our sand particles, you imagine sand out in your sandbox. It's very angular, little blocky structures, kind of jagged edges. And this is our silt and sand particles, their shapes and sizes. So if we take the percentage of each of these in our soil, that's how we determine our soil texture. And usually what happens there is that we'll send our sample to a lab of some sort, or there are some other ways we'll learn in just a little bit of how we can determine the texture. So the lab will analyze the soil and it will come back and say, this is how much sand you have, this is how much silt you have, and this is how much clay you have. So for example, the lab could tell me I have 25% clay, you have 40% silt. And if I want to find out percent sand, it's really easy to do because we have 100% of soil out there. So we subtract that 25% clay, we subtract the 40% silt, and then we know that the sand content is 35% sand. And if we only knew silt and sand, we can do the same thing to calculate clay. So once we have that information, we can then go to what is called a textural triangle. And with this textural triangle, we can then determine the classification name of the soil texture that we have. So here's our texture triangle. And on one side, we have our clay percentage. And it goes from 0% clay to 100% clay. And over here, we have our silt, separate percent, so percent silt. And we go from 0 to 100% clay, or silt, sorry. And then from here, our bottom is our sand. So we go from 0 to 100% sand content. So if we want to figure out what texture we have based on our example here, we'd find the clay percentage right here at 25% clay. Then we'd find the silt percent at 40% silt. And then our sand percent, which is 35%. From here, we follow the lines inside until they intersect. And once they do that, whatever box or whatever area that we're in, that's the soil texture class. So this point falls within this box right here. And so this, we would say, is a loam soil. Now, if we fell inside over here, at this point, we'd be a silt loam soil. If we were over here, we'd be a sandy clay loam. Up here, we'd be a clay soil. So we can imagine doing this for if we got different measurements of sand, silt, and clay, we could use this triangle to really figure out what the texture of our soil is. And based on the texture of our soil, that affects how well we hold water, how well we hold nutrients, how well crops and plants can grow. So sometimes we don't want to be extremely specific on what our soil texture is. Sometimes we can only have like a ballpark estimate. So what we do is we have three general classifications as well when we talk about soils. We have this group over here, which has our high sandy area, lower clay, and lower silt. So this is deemed our coarse textured soils. Over here, where we have lower sand, lower clay, but higher silt, this is a medium textured soil. And then this top area is where we have higher clay, but lower sand and lower silt, and we term that as our fine textured soils. So based on our soils and their texture, we can then kind of deem them into these general categories, which helps us talk about things a little bit more generally. And if we look just at the soils of South Dakota, here we pull up a map of South Dakota, we tend to see two general characteristics. If we look on this eastern side of South Dakota, we tend to see a medium textured soil, so a little bit more silt, a little bit more sand in the soil. Whereas if we get farther west, we see a little bit finer textured soils. And this all has to do with how these soils were made many years ago. Over here in this area of the state, in this pinkish area of state, we had glaciers that came through. And glaciers tend to carry soil particles that are larger. They have more sands in them, more silts in them, less clay, and they tend to drop them as those glaciers kind of came through and then receded. However, we contrast that with the western part of the state over here, where we have more of these fine textured soils. This area tended to be developed more with lake sediments. So we had prehistoric lakes in this area that eroded different areas, and those lakes tend to carry clay particles, and lots of them, because clay stays suspended in water for a long period of time before it settles out. So when those lakes kind of dried up, they left a lot of clays in that area, so that resulted in more fine textured soils. If you want to know a little bit And also over here, before I forget, once we get to the website, we have in Black Hills areas a lot of mixed soils, the different colors represent different. If you want to know a little bit more about how these soils developed, that led to the soils that we have today. There's a link right more of a pink area here over in East River, take us to a website, and more of a green, yellow areas over here in West River, and that leads to the different soil types that we talked about a little bit earlier in each of these sides. So if we click here on the pink areas, then we can scroll down here, we can see it's a little description of what happened to reach the soils that we have today. So this area over here was mostly formed through glaciation. The glaciers came through and it deposits materials, and glaciers tend to deposit more gravels, more sands, and more silts. Heavier particles fall out of them as well. Whereas if we contrast that to this area over here, the greens and the yellows, we read a little bit more about those histories here. We can see that these areas were formed more through ancient lakes, and lakes tend to have more clays in their waters, so that murky areas stays in suspension. So when those lakes dried up, it left those clays there, which equal our finer soils in that area of South Dakota. So this is an excellent website to come, explore a little bit, learn a bit more about the soils in our state of South Dakota. All right, the next thing we're going to kind of talk about is how we determine the amount of sand, silt, and clay in a lab test. We talked about them generally and how we determine them once we know them, but what does the lab do to determine the amount of sand, silt, and clay they do? There's a couple different tests they can do. The first one is called the mechanical sieve analysis, and this is a YouTube video that you can watch, and I'll put the link on it in the Training House module so you can take a look at it if you would like to. And what this does, it's really looking at that sandy, gravelly portion of your soil. So it has these different sieves you can see here, and they have different meshes in the bottom. Larger meshes at the top, smaller ones at the bottom. And they shake the soil down, and based on how much soil is held within each sieve, it then relates to how much of the different particle sizes are in that soil. But we're usually concerned with that finer fraction, those sand, silt, and clays. So to determine that, they use what's called the hydrometer method, and that's the method shown here. And with that method, what you can see over here is that we have the soil that was put in a water solution, and then it's mixed up really well, and from there it's let settle. So you can imagine sand is heavier than silt, silt is heavier than clay. So the sand fraction comes out of suspension faster, and then you wait a little longer, then the silt fraction will come out of suspension. Then what's left is the clay fraction. So based on the amount of sand, silt, and clay that's in this hydrometer method measures, we can then use that to determine soil texture. And if we want to be able to determine soil texture at home, we can follow this link right here, and we'll do so in just a second here to show us more of a way we can look at this at our own houses and do it in a way there. Once we get to the link that talks about the soil texture analysis that you can do at your house, you'll come here, and then you'll scroll down and you'll see those things that we need. Biggest thing we need is we need a clear jar with straight edges as much as possible, and we need some soil. We want to fill out the soil to be about a third of the way full. And we want to take out any sticks, debris, large organic matter, roots, and things like that as much as we can. Then we're going to fill the remainder of the jar with some water, but we want to leave some room right here up at the top so we can shake it really well. The next thing we're going to do is we're going to add a tablespoon of dishwashing detergent or of borax dishwashing soap. And what that does is that it helps the soil kind of disperse or move away from each other, and breaks down that glue that leads to those particles to join together, and then will help them come out of solution more easily so we can measure them. So what we're going to want to do, once we shake it vigorously for about 5 minutes, we're going to set it on the surface of a counter, we're going to let it sit. And after a minute or two, we're going to make a mark, and that mark is going to be just above where all the particles have settled out. So right here, and this represents our sand in our soil because it settles out very quickly. The next thing we're going to do is wait for 2 hours, and after 2 hours, the silt in our soil should be settled out, and we're going to make another mark like this one right here. And then we're going to wait for about 48 hours. That's about how long it takes to get those clay particles to really start to settle out. And it's important that we add that soap to help those clay particles sink. If we don't, we might have a murky soil for days and not really get it settled out. The next thing you're going to do is you're going to measure each of those distances between each line. And then you're going to take the percent of the total of each one. And that percent of sand, of silt, and of clay, the small area up here, is going to be what you're going to use for your texture triangle to determine soil texture, that you have in your lawn or garden. This is kind of an easy at-home way, not quite as accurate as the labs, but it's kind of a fun at-home science project as well. Another aspect of soil texture that's really important is that the fact that these different soil particle sizes, what they do is they really influence the size of the pores in the soil. So you can imagine larger particles have larger pore sizes, smaller ones have smaller pore sizes. And if we look kind of at an illustration down here, we see these larger particles are more of the sand-sized particles, the smaller ones are the silt-sized. And if we want to see basic relative to what a clay size would look like, you can imagine this period that's bracketed here, right here. This would be about a stack of 20 clay minerals stacked on top of each other. It's the size of that period. So imagine how small those pores are in relation to silt and sand. So here we see the smaller pore spaces with silt versus the larger ones with the sand. And these all go into kind of combining together because you're not going to have a soil that's just sand and just silt or just clay, and they kind of interact together to create some small and large pores. However, as we saw earlier, we have soils that are more dominant with sands, more dominant with silt, more dominant with clay, and with that we can kind of get different attributes, generally speaking. So if we look here at a fine textured soils, those clays, clay loams, silty clay loams, and look at some of its characteristics, we can see that they tend to have high nutrient water holding capacities. So they have a lot of surface area, they have a lot of smaller pores, which is able to hold that water really well. So about 2 to 3.5 inches of water per foot of soil. So that's a good amount of water that it's holding. However, with small pore sizes also does equal pore drainage because it takes longer for the water to move down through those small pores. And also, small pores can make it a little bit harder for roots to go down and kind of find their way through there. And because the soil tends to be wetter, water takes a little bit longer to warm up in the spring, so it causes these fine textured soils that generally hold more water to be a little bit slower in warming up in the springtime before we can get them planted and get our gardens and lawns growing again. So if we contrast that to a coarse textured soil like we see here, we see a lot of sands that are in there, a lot of larger particles. These are sand, loamy sand, sandy loam soils. Imagine it has just about the opposite attributes. We're looking at a low water holding capacity, only about up to about 1.3 inches of water per foot of soil. And then here, instead of not draining well, we drain really well, which is hard to hold water. And so it drains through there really well. Just think of a sandbox, water goes through there pretty quickly. And coarse textured soils tend to be low in nutrients. They have large pores, can't hold on to those nutrients as well. So here's your quiz question now. So we've been through this first section, look at the soil physical properties. So here's your question for you to kind of think of. So go ahead, after I explain this a little bit, hit the pause button, answer these couple of questions, and hit play again, and we'll see how well you did. So you get a lab test back from the soil testing lab, and it reads 5% organic matter, 20% sand, 20% clay. So go ahead, first question, calculate percent of silt. Then once you have that, go ahead and determine your soil texture class. So go ahead and hit pause, and we'll be back with you in just a second. We'd hit some Jeopardy music, but I believe that's copyrighted, so we'll just go for the silent treatment here for a second and let you guys figure this out. Alright, so we're about to reveal the answers, so if you haven't hit pause, now's your chance. Hit pause, figure these out for yourself so you can calculate them. Otherwise, here we go. So if we take 100% of our soil, we subtract 20% sand, 20% clay, we get 60% silt. And then, if we take those measurements, 20% sand, 20% clay, 60% silt, go together, we see right here. In this category, we're looking at a silt loam soil. So there's our answers for those two questions. If you have more questions about how to do this, go ahead and go back a few minutes and relook at that section of our presentation. So there's these lab methods that we talked about to determine soil texture, but we don't always have a lab. So we also can use what's called the feel method. Now the feel method is where we get a handful of soil and we work that soil, and we get it wetted down, and we work it with our fingers, and we create a ball of soil in the palm of our hands. And the next thing we do is we squeeze that ball of soil between our thumb and our finger, and we create a ribbon that's about 1/4 of an inch thick. And based on the feel of that soil, the feel of the ribbon, and the length of that ribbon before it breaks, we can generally determine our soil classification, whether it's a fine, medium, or coarse textured soil. So if we want to look at these approximations, we can kind of think, again, fine textured soils, high clay, lower sand and silt. So these form a long, shiny, sticky ribbon. So they form the longest ribbon of them all. They're a little stronger, and when they dry, they're these hard clods. Compare that with a medium textured soil. These ribbons aren't as strong. They're not going to be as long as with fine textured soils, but they're not going to feel gritty. When they're dry, the soil almost has a floury feel to it. That's the silt that you're feeling, is that floury feeling. And then if we go to coarse textured soils, we're not really going to get a ribbon at all. We're going to try and create a ribbon, and it's just going to break right off. And we're going to almost be able to feel that gritty feel that's in there. And we can probably even see some of the mineral particles, that sandy particles that are there. And don't worry if you didn't quite get this from this presentation. In the handouts in the section, you'll be able to find a YouTube video that'll visually show you, walking through you about how to do some texture analysis. So next, we've gone over soil texture. Now we're going to go over soil structure. So soil texture was the amount of sand, silt, and clay we had in the soil, and now soil structure is the way those individual particles of sand, silt, and clay are assembled together in a soil. So if we start with the most basic structure of a soil, it's called single grain or almost structureless. So it almost looks like a sand pile. It's a single grain of each particle. And this is not what you want. What you want in your soil is you want those different particles of sand, silt, and clay to form kind of larger particles called aggregates. And this one that kind of is marble size, a little bit small, a little bit bigger, this is granular. This is that soil texture or soil structure you want in the top of your soil, that top 6 inches. And then there's another structure called platy, and this looks just about how it sounds. So if you dig down in your soil, sometimes you can see almost what looks, if you look at that profile after you've taken a shovel out, you can almost see little plate-like layers there, and that's usually due to compaction from a vehicle or from constant tillage across the same area, and then some compaction. It pushes that soil down together and creates almost a plate-like structure in the soil. And the next one is called prismatic columnar, and it looks about how it sounds. It's a prism or a column, kind of like a rectangular block. It's a little bit longer than it is wide. And these are usually a little bit deeper in the soil, and they're made from different particles, larger particles coming together. And the next one is blocky, so it is what it looks like, what it sounds like. It's just these block-like structures in the soil. And then angular blocky is if you just take those blocky structures and cut off the edges, make them a little bit different there. And these are all fairly similar looking, and they're usually a little bit deeper in the soil. But what's really important here is in order to make these different structures in the soil, we need some type of glue to bring them together. And that glue that we're going to have comes from different things that are living in the soil. So things like exudates from microbes, from roots, the organic matter that's kind of breaking down, has sticky substances in it. It brings these particles of sand, silt, and clay together to form these different structures, which are important because they help with nutrient retention, they help with keeping water in the soil, and keeping nutrients as well. So if we were to look at what would be called a favorable soil structure, this is a picture of a soil down in the southeastern part of South Dakota that I was able to sample a few days ago. And if you look at that soil in my hand, you can see these granular type of structures, these small pieces right here that look like the size of marbles, different roundness, different squareness, and you can see them there. This is a really good soil. This is a soil structure that we want in the top of our soil. And what that granular structure does is it improves water infiltration. So when we get rain, we irrigate, that water can get into the soil and be held by the soil, but also allows roots to go down through those different aggregates, creating bigger pores and areas for them to get down deeper into the soil so they can get nutrients, and also so they can get the water that they need in a deeper soil area. So far we've gone over the composition of our soil. We've talked about some soil properties, physical properties, looking at soil texture and soil structure. In our following videos, we'll look more into some of these other soil biological, soil chemical properties, soil essential nutrients, and how we can improve our soil properties to make our crops grow even better. So that's it for now. Go ahead and click on the next video in the set, and we can continue to learn more about soils and how much they can do for us. If you have any questions, also, here's my information. Feel free to reach out. Thank you so much.